A very good morning to all. Today we will look at part 2 of solution preparation and we will discuss about serial dilution, its concept, as well as clear some of the general misconceptions. Let us look at some of the key points regarding serial dilution. So a serial dilution is a stepwise dilution where the dilution factor at each step is constant. So it can be either a 1 is to 10, 1 is to 100, 1 is to 1000, 1 is to 10,000, or 1 is to 2, 1 is to 4, 1 is to 8, and so on. So if you look at the first dilution, we can clearly see if you divide 1 is to 100 by 1 is to 10, we will get 1 by 10. Or if you divide 1 by 1000 divided by 1 by 100, we will get 1 by 10. So at each dilution, the dilution factor remains the same. Or if you look in this case, 1 by 4 divided by 1 by 2, we get 1 by 2. We'll get even if you do 1 by 8 divided by 1 by 4, we'll get 1 by 2. So here we are doing a 1 is to 2 dilution, and likewise we can do any such dilution. It can be either 1 is to 3, 1 is to 9, 1 is to 27, and so on. Now what is the use of this? We can make high diluted solution. So this with if you have enough solvent, we can keep on doing this serial dilution and get infinite amount of all these dilutions. It is also used in bacterial culture where they have to dilute the bacterial load in such a way that it comes in the range of where it is countable, or whether it can be to reduce to a volume of a particular concentration as they wish. Now, it is also used in cell culture, cytotoxic, and other bacteria screening, where you can screen down we can look at a range of concentration and screen down to which concentration is the particular drug or compound effective. We also can do serial dilution, especially in case of homeopathy. Serial dilution is one of their major foundation practice, where they call the dilution or serial dilution as potentiation. So we will look at one of the dilution that is usually seen in most of the textbook. We will perform a 1 is to 10, 1 is to 100, 1 is to 1000 such dilution in total volume of 10 ml. So we have the stock. We will take tube to dilute the particular stock. We have to take 9 ml of the solvent. Since we are doing a 1 is to 10 dilution, we have already studied, like we have to take 1 ml from the stock and then make up to 10 ml using 9 ml of solvent. This is how we usually do a 1 is to 10 dilution. And since we know at each step we should be doing 1 is to 10 dilution, we have to take 9 ml of the solvent, take 1 ml from the main stock, and then add that into the first tube. So if you add 1 ml to the first tube, the concentration there will be 1 by 1 plus 9, 1 ml of the stock plus 9 ml of the solvent. So the same thing is repeated in each and every tube, and we will get the dilution of each tube. So if you look at tube 1, we have a 1 is to 10 dilution. In tube 2, we again have a 1 is to 10 dilution. In tube 3, again 1 is to 10. So each step we are diluting 10 times with respect to the earlier tube. Now what will be the final concentration in each tube? So how can we find out? So in first of this tube, we have got 1 is to 10. In second tube, we have diluted the first tube again 1 by 10 times. So you multiply 1 by 10 into 1 by 10. That will be the dilution in the second tube. In the third tube, we are diluting the second tube again 10 times, which means 1 is to 100 into 1 by 10, which is 1 by 1000. And similarly for the rest of the tubes, and we can even say 1 by 10 as 10 raised to minus 1, or 1 by 100 as 10 raised to minus 2, and so on. And this is how the serial dilution is done. Now let us perform the same dilution for 5 ml. So usually there is a misconception, like whenever anyone is asked to do a 1 is to 10, 1 is to 100 dilution, the first thing they will do is take 9 ml of solvent, add 1 ml, and make the dilution, even if the required amount is less than 10 or the required amount is 3 or 4 ml. So we don't have to waste the reagents. We can make whatever is required. So say for example, we can also make the same dilution in whatever amount we need. So how to calculate that? So again, to calculate that, what we have to do, we know the serial dilution, the dilution at each step is 1 by 10. So 1 by 10 into 5 gives you 0.5. So what you mean by 1 is to 10 is like always the solute will contribute one part of the total 10 parts. So the rest 9 part will be the solvent. So if you want to find out how much of solute or how much of stock you have to take, it should be done like 1 by 10 into 5, which is zero point 0.5, and you can like subtract zero point 0.5 from 5 and get what is the amount of solvent that you have to add. Or to make the concept more clear, it is 9 by 10 into 5, which is the solvent amount. So 9 part is the solvent amount in the total mixture, and that is how we do the serial dilution. So again, we'll take the 5 different tubes and then we will do the similar dilution. So here if you see, we are adding 0.5 ml into 4.5 ml solvent. So the dilution that happens there is 0.5 divided by the total volume, which again is 0.5 divided by 5, which we can write as 1 by 10. So in each step this is happening. So each step 1 by 10 times it is getting diluted, and like what we did the last time, just multiply the both the dilution, we will get what is the dilution in each tube. So in this tube we know it is 1 is to 10. The second tube we have diluted the already diluted 1 by 10 solution again 1 is to 10 times, which means we have to multiply 1 by 10 into 1 by 10, which is 1 is to 100, and similarly 1 by 100 into 1 by 10, we will get 1 is to 1000 in the next tube, and this is how we do that. Now let us do the 1 is to 2, 1 is to 4, 1 is to 8 dilution. So we don't have to waste too much of time. We know how it is done. So 1 is to 2 means half part should be solvent, half part should be from the stock. So if you are making total 10 ml, so 1 by 2 into 10, 5 ml should be from the stock and 5 ml of solvent should be added. So we add 5 ml of solvent in each tube, take 5 ml from the stock, do the serial dilution. So between each step it is very important that we mix the both the stock as well as the solvent properly, otherwise whatever we take into the next tube may not be a uniform mixture and the concentration can vary. So if you look what is the dilution that is happening here, 5 divided by 5 plus 5, which is 5 by 10, which is again 1 into 2. Now this is 1 by 2 diluted solution. This again we are diluting it 1 by 2 times. So the total dilution in this tube will be 1 by 2 into 1 by 2, which is 1 by 4. Now in the third tube we are diluting an already diluted solution again 1 by 2 times. So this is a 1 by 4 diluted tube into 1 by 2. So 1 by 4 into 1 by 2 we will get 1 by 8, and similarly in the subsequent step all the dilution will happen. Now let us take one step further. Now if you have noticed the initial example where we did 1 is to 10, 1 is to 100 dilution to the total volume of 10 ml, you would have noticed that after the dilution, all the dilution was done, the amount in each of the tube was 9 ml and it was not 10 ml. And imagine a condition where like you require 10 ml of each of this dilution, that particular method or what that particular way does not work. So you should know the exact concept behind this serial dilution, which we have already discussed, but we will revisit it again. Now to have 10 ml in each of the tube after the serial dilution, we have to calculate it like 9 by 10 into the total volume will be equal to 10, which means we already know the 9 part of the total 10 will be contributed by the solvent and 1 part will be the stock that will be mixed to that particular solvent. And again after mixing we will take that 1 part again to the next tube during this 1 is to 10, 1 is to 100 dilution. So whatever will be remaining is equal to the amount of solvent. So to calculate, we have to do the 9 by 10 into A should be equal to 10. Then we will find A, which is A equal to 100 by 9, which is 11.11, which means the total volume will be 11.11. Now to know the amount of stock that should be added to this 10 ml, we have to subtract 10 from 11.11, which is 1.11 ml. So this is how we will be doing it. So we will take 10 ml in each of these tube, then add 1.11 ml and mix properly, then do the serial dilution. So see what happens. So 1.11 divided by total 11.11, which is 10 plus 1.11, so that is equal to 1:10. So we are maintaining that ratio, but at the same time we are getting 10 ml after each dilution. So this is done in similar fashion as we have done earlier, but then if you understand this concept properly, then we can calculate for whatever amount we require for a particular dilution. So as you have already said, if you require just 1 ml of 1:10 dilution, we don't have to make 5 or 10 ml. The only thing that we have to do is mix 100 microliter of the stock and 900 microliter of the solvent, which is also a 1:100 dilution. Sorry, it is also a 1:10 dilution. So I hope the concept is very clear, and I hope you will be able to do any serial dilution, any amount that is required after watching this video. Thank you so much, and stay tuned for more on solution preparation.